Interesting. I can't find my own streaming. Oh, there we go. Okay, there you go. This is it.
I just got push notification that you are streaming.
Yeah, but I'm checking the audio because some of my other classes were talking about the voice is kind of not working right. So I changed some of the settings already, but I had to double check and verify it is okay. Nope, it's supposed to be live.
It is working.
It is? Okay.
Yeah, but I'm checking the audio because
There we go.
other classes.
Time loop.
A little quiet though, but it's working.
A little quiet? Well, the mixer has a pretty good, signal strength here. So I'm not sure why it is quiet.
Maybe it's just my tablet. It's kind of
It could be.
strongest.
Okay. All right. Well, it's time.
You're checking the mixer volume on OBS or your actual Windows Linux?
The actual streamed result on YouTube. So I'm checking the end result of the streaming. And it seemed to be okay this time. All right, so I turned this into an actual homework now. Remember last time I kind of said that, this is a maybe, graded homework assignment. It is now, but it's due on Monday. So if you started early and you got it done already, you just have to submit it and turn it in. There's no special requirement this time, to use a particular file that I start with, but the standard still has to be the same. Okay, so you guys still need a line number column, utilize return info the same way that I do in class, that sort of thing. Yep. Then you can just go in and turn it in, through the Canvas interface, because that makes it easier for me to grade, because there's only one place I need to look to find submissions. So if you have turned it in, 2 people turned it in by email already. So if you are one of those people, just go ahead and submit it again on with Canvas. You can submit a different version, okay? After today's lecture, if you decide, oh, okay, I want to change something, that's fine too. It's due on Monday, so you have until like Monday before the class to turn it in. All right. So are there any questions about recursion, about subroutines and stuff like that? No particular question? All right. So what we'll do today is to kind of mix and match concepts that we have already been introduced to. So we have done subroutines, we have done return values, we have done parameters, passed by value, passed by reference. We have local variables, and then we have arrays. And we haven't really mixed in the concept of arrays with subroutines. Okay, so that's what we'll be doing today. At least, initially, we'll see how much time we got and how far we can get. So are there any questions about that? No questions? All right. So we'll go ahead and get started with those concepts, and I'm going to use my mouse pad, which is kind of like a notepad, to write the code first, and then when we are done, then I'll go ahead and copy and paste it into the spreadsheet before I trace it. All right, so what we'll do is we're going to define some subroutines, and then we'll start to, so don't try to copy this because I'm not writing the program in a sequential manner. And the streamer should be streaming because we checked a little bit earlier. It is streaming and the audio is good. Okay. So we'll define main, and then we'll have a local variable. But this time, this local variable is not just a single variable. It is an array now. Okay. So I'm going to call this variable A, and we're going to use this notation with a colon that says what kind of variable is this? This is an array of for now, we'll just say an array of 5 items, okay? Because we haven't really introduced the concept of a type, so we're not going to say what kind of items they are. If I don't say anything, they're usually just numbers, just integers and stuff, okay? All right, and then we'll go ahead and invoke a subroutine, okay? So we'll say if invoke find, okay? So we'll define the subroutine find a little bit later. And then we'll pass local variable a as a argument to, okay, let's call this x in the subroutine. And then we'll also try to find a particular value, let's say 5 in the array. Okay, else print not found, and if. Now, because a is a local variable, it's not initialized. So now I have to go ahead and initialize those particular values. So I'm just going to pick some random values here. A bracket 0 has a value of 3. A bracket 1 has a value of 5. A bracket 2 has a value of, let's say, 14. A bracket 3 has a value of 21. And then A bracket 4 has a value of, let's say, 31. Okay. So this is the main subroutine. Now we are going to define find, which is going to implement a linear search algorithm, which you have seen already, just not in the context of a subroutine. So right away we know that find as a subroutine has 2 parameters. We know it has 2 parameters because of the way we use it. On line 11, when we invoke find, we have to specify parameter x. We also have to specify parameter k. So we know it has 2 parameters. And we know that x is passed by reference because it has got a double-sided arrow. The other one, we know it is passed by value because it has a single-sided arrow pointing to the right-hand side. So k, which is the abbreviation of key, is just a single number. So if you want to, you can just say it's a number. X is an array of numbers, okay? And we can just change these, so that we're consistent here. There we go. I would need a local variable for find. Local variable I is also a number. And then right here, we're going to write the usual logic for finding a particular value in an array. And we'll implement the straight linear search algorithm. So we are not even going to say, oh, if the input is sorted, I can do it faster. We'll just implement it using the most, the simplest logic. So that means, we have to initialize I to 0, which is the index of the first element of the array. As long as I is less than bar x bar, and as long as A bracket I does not equal to, I use that symbol to mean not equal to, Oh, right, okay. That's right, thank you. So x bracket I does not equal to k, do the following. All we do is we advance the index by 1, and while. Now we have to return a value because we have to indicate whether the value k is actually found in the array x or not. So we have to return a value. In this case, we're not going to be returning a integer. We're going to be returning a Boolean, something that is either true or false. Okay, so we're going to return. It is not the we're going to return I is less than bar x bar. Okay, because that is the same thing as saying, yep, we found it. Okay, so before I trace the code, are there any questions? Because if there are any questions, now would be a good time to ask before we start tracing it. Yep.
How do you return the value for if it's a Boolean?
Well, you return a Boolean just like you return an integer. Because a Boolean value, true or false, is really just a value. So a subroutine is not limited to only return integers. It can also return Boolean values. Yep.
Can you say
Well, if you say return true, that means you're returning true all the time. Whether the value k is in array X or not, you are returning true, which means, from the caller's perspective, you're basically saying, yep, that value k is actually somewhere in array X. But that may not be the case, so you cannot return a constant. Yep.
So if x bracket I does equal k, it's going to return false?
It will return true. Okay, so let's analyze this code. Okay, so let's go ahead and analyze the code first. Are there any questions about why I is initialized to 0? And as long as I is less than bar x bar, which is the number of elements in the array X, we can potentially stay in the loop, and also why we are incrementing I in the loop. So are there any questions regarding how we change I and how we check the boundary of I? No questions? Okay. I get 0 because 0 is the first available index of the entire array. I has to be less than bar a bar because when I becomes bar a bar, it is an invalid index of the array already at that point. So we better get out of the loop. And in the loop on line 7, we are incrementing I because, hey, that element of X does not equal to K. What should I do? Well, let's move on to the next one and see if the next one has the value that we are looking for. Okay? What was the question? Did you guys have a question? You had a question. Okay. So now the question is, how is this loop going to exit? Okay. There are two reasons for this loop to exit. Go ahead.
You either find k in the array or you run out of spots to check.
That's right. So if this condition becomes false and that's why we're exiting the loop, that means we have looked into every single element in the array and none of them has the value k. So in that case, when I is not less than bar a bar, then I should be returning false because the value k cannot be found in the array. Is that okay? All right. Yep, but since I'm here, might as well explain the other reason why we'll be exiting the loop. So the other reason to exit the loop is when this condition is false. When this condition is false, that means x bracket I does equal to k. Well, it's a good condition to exit because we just need to know whether k is in the array or not. As soon as we find the first occurrence of k in the array, hey, we can get out of the loop. But if I do get out of the loop because of this condition, what does it say about the condition I is less than bar a bar? It has to be true. So that is why we can use I is less than bar a bar as the Boolean value indicating whether the value k is found in the array X or not. So are we good so far? Okay. So now the next question, okay? Because I have a lot of questions. I look at this code and go like, hey, what about this? It doesn't seem like I'm changing anything in the array. So can we pass this by value? In other words, we are making a copy of the entire array and then send that copy of the entire array to the subroutine find, because that's what by val does. So the answer is kind of interesting. In concept, yes. Okay. In concept, if you're not changing the array, you might as well. You can always make a copy of the array and then send that copy to the subroutine. That's fine. But in practice, you cannot. In C and C++, there is no way to pass an array by value. That is just basically a limitation of the programming language itself. So when you need to pass an array to a subroutine in C and C++, you have to pass it by reference. It is always passed by reference. Is that okay? So that's kind of a language-related issue, but since almost all of you are moving on to CISP360, and C is going to be your actual programming language, I kind of have to mention that and basically respect that limitation of C and C++. Is that okay? All right. So we'll now go ahead and trace the code. Okay. So this code is just do a Control C to copy it, and then start my. It's okay. It's looking for a file that wasn't that was there, but now it's not. All right. And it seems a little small. Okay, that's good. We'll have to scroll the code a little bit. And then we'll have another tab for the trace. And in case anyone is curious, I am using the HDMI to VGA converter that arrived today. I tried the other way, it just wouldn't work. It just would not work with my USB-C to VGA converter. So, all right, so we got line number. There are no global variables, so we have nothing to say about that. And I think I forgot about invoking main. Yep, I did. So we'll say invoke main here. So the first part of the trace is just kind of focusing on main. On line 24, we're invoking main. So we'll use return info. When we return, we're going to return to post. Okay, that's the easy part. So the second part is a little bit more challenging because we have a local variable A, but local variable A is not a single thing. It is an array of 5 items. So what we're going to do is to use the same standard as before. We're going to use 5 columns, 1 column per element of this array. Okay, so it's going to look like this. Okay, it's going to be quite tedious. So instead of using 2 different rows, I'm just going to use A bracket 1. And because this is actually my computer, I'm going to spend the time to turn off, how do you call that? Autocorrect. There we go. So I'm going to turn off most of the options of autocorrect. Use replacement table, I do want that. Do not capitalize, do not automatically boldface. We can even strike out. Ooh, okay, I might want to keep that one. Yep.
Is there a reason why you haven't set up like a key mode for shutdown?
Well, this is a brand new install, so I haven't.
Well, I mean like with your prior.
With my prior, yeah, I'm just too lazy to do that. And I've been using Google Spreadsheet also. And with Google Spreadsheet, you can set up your own function too. If you know how to do JavaScript, you can do a lot of things in JavaScript. Correct accidental use of caps lock. Turn that off. Okay, so I think this should be better. So A bracket 0, A bracket 1, A bracket 2, A bracket 3, A bracket 4. All right. There we go. So initially, all of these columns have question marks because they are all basically local variables. So sometimes you can look at A as one single thing, and other times you can look at A as individual things. So now we have set up main, and now we can start to execute the program inside main, starting on line 13. So this is nothing exciting. All we are doing is to initialize elements of array A. So we got 3, 5, 14, 21, and 31. And they're all on consecutive lines. There we go. All right, so the question now is on line 18. What are we going to do when we call a subroutine that returns a value that is going to be utilized in a conditional statement, and we are passing an array by reference as a parameter into that subroutine? So we got quite a few questions, okay, right here. Okay, first question first. The first question is, how do we represent the return info in this case? Return info, you have to remember the purpose of return info. The purpose of return info is by the time the subroutine is done, I need to know where to get back to and what else I need to do when I get back to that line. So that's the main objective or the reason why we need return info. So understanding that that is the reason of the return info column, then we can now say, oh, okay, if that is the case, we need to remember that we need to go back to line 18. But when we get back to line 18, we have the conditional statement to deal with, but the condition of the conditional statement would have been specified by the return value of the invocation of this subroutine. So that's why the entire invocation, including the specification of all the parameters, is reduced to a single question mark, which is the placeholder of the return value. Is that okay? As awkward and weird as it seems, that's how we represent the return info here. Okay, to emphasize that when we get back to line 18, we still have to evaluate the condition and then perform the branching accordingly. Then what about the parameters? There are two parameters. Let's deal with the easy one first. K is the easy one. K is easy because it is just a by-val parameter. Oh, I forgot to do that, did I? Nope. Okay, so K is just a by-val parameter, pretty easy, is a single value. So we'll just say that, okay, we're passing 3 to K. That's the easy part. Sorry?
It's 5.
Oh, it's 5. Okay, I'm looking for 5, so we'll put 5 here. Excuse me. The difficult one is X. Because X is passed by reference, we kind of know how to do pass by reference when we're only passing a single variable by reference, okay? It becomes a reference to a single column. But now we are passing an entire array by reference. So what are we going to do? Well, in this class, we're just going to say X refers to, okay, I hope I didn't write on the other one, okay. So we'll say X refers to, but this time it's referring to a bunch of columns. So it's going to be referring to column C to column G. Okay? So instead of being a reference to a single column, it is now a reference to multiple columns. Okay? The actual mechanism in C and C++ is not exactly that, but we don't have the vocabulary in this class to express that, because I don't want to throw pointers into the whole thing, because that's basically how C and C++ is going to do it. So we'll go ahead and try to use this approach to explain it. So now that we have everything allocated, we still have one local variable I. So local variable I is also easy because it is just unknown being a local variable. Yep.
Where do we insert comments for the conditional statement?
Aha, I forgot about that. So we'll put a column between A and B. So we'll insert a column to the left. There we go. Thank you.
Does that change the reference for X?
Yep, it's going to change the references. So it's not going to be from D to H. There we go, thank you. All right, so now we can go into the subroutine and start to execute on line 5. Line 5, oops, uh-oh. Line 5 is going to initialize local variable I. So local variable I is now initialized. Initialized is 0, not 5. Yep.
Is there any way you could lock the first 2 columns in place?
Yeah, I can.
3 columns?
You mean like this?
Yeah.
And I can make this a little bit narrower.
That way you don't have to scroll back and forth.
Yep. That's the downside of using a lower resolution projector. Most of our other classrooms are using 1280 by 720. This one is just XGA, so we are losing about 200 something pixels. It's kind of significant. All right, so that's a good idea. Good job. So then on line 6, we have to evaluate the condition. The condition itself is going to be a little bit more complicated. So what I'll do is I'm going to turn on line wrapping. All right, So I think it's under alignment, and we want to wrap text. There we go. Okay. And then we have to remember which line, line 6. So okay, on line 6, with comments, we have to look at both of those conditions in the conjunction. The first one is I is less than bar x bar. Bar x bar is dictated by how many columns it's referencing. So D, E, F, G, H, 5 columns, okay? So because X is referring to 5 columns, then bar X bar is going to be 5, okay? 5 is greater than I, which is 0 at this point, is true. So with a conjunction, if the left-hand side is true, then I have no choice but to also evaluate the right-hand side. The right-hand side says, we want to compare X bracket I with K. So now the question is, what X bracket I are we talking about? X is a reference to a bunch of columns. So what you need to do now is to apply the bracket to the columns being referenced by X. So X bracket I, so first of all, you have to evaluate I. I is 0. So we are looking for X bracket 0. So X bracket 0 is basically saying the first item of X. But then we look at X and go like, but X is not, X doesn't really have any values because it's a reference. But it's a reference to 5 things. So out of those 5 things, we are only interested in the first one. So it is actually referring to A bracket 0 of Maine, which has a value of 3. And so we are comparing 3 and 5, they do not equal. So those things being different is also true. So now we have true and true, so the end result is true. Because the condition is true, we continue on to the body of the loop, which only has one thing to do on line 7. On line 7, the only thing we have to do is to increment I. So I is now incrementing from 0 to 1. Then we get back to line 6. When we get back to line 6, we evaluate both of those conditions again. I has a value of 1. Is it less than bar X bar? X is referring to 5 columns, so bar X bar is 5. 1 is less than 5 is true. So now we have to evaluate the second condition. X bracket I. I is 1. X bracket 1 is basically saying the second thing of X. So we look up X. X is not an array by itself, but it is a reference to 1. So we are really looking at the second item of the array that X is referring to. Is that okay? But since X is referring to the to columns D, E, F, G, H, column E is the second item, and column E has a value of 5. That has to do with line 14, initializing A bracket 1 to 5. 5 equals 5 is true. Well, if 5 equals 5 is true, then 5 is different from 5 is false. So now we have the result of the conjunction being false. So we're going to get out of the loop. When we get out of the loop from line 6, we're jumping all the way to line 9. Line 9 is returning a Boolean this time. There's no particular trickiness to returning a Boolean as opposed to returning a number, because you can return any value. Okay, a number is a value, but a Boolean value like true and false is also really just a value. So there's really no difference between those. So in this case, we're returning the result of evaluating I is less than bar X bar. What is the current value of I? 1. It's still 1, and then bar X bar is 5. 1 is less than 5 is true. So we are returning the value of true. It doesn't really change how we do the return. When we do the return, we are copying and pasting the return info cell. And all we are going to do is to change the question mark to the value that we are returning. In this case, because we are returning true, the question mark is now replaced by true itself. Do we have any questions? Yes?
So right now so if 5 was in, say, spot number 3 in the array, you would be returning 3?
No, because it's returning the result of a comparison. So it can only be true or false. It's not returning I itself, it is returning whether I is less than bar a bar. Okay. Now we get to line 10, which is the end of the subroutine. So on line 10, we are going to do two things. One thing is, the first thing is to take a note of what else do we need to do when we get back to line 18. So that would do that. And then the next thing we're going to do is to deallocate the 3 columns. So I'm going to try out that, strike out replacement thing. No, it doesn't work. That doesn't work. I thought that's the shortcut to do it. Oh well. So we do the long way. Now we do the strikeout. There we go. So after we deallocate columns I, J, K, and L, our current context returns to this part. And then we are now on line 18. So we are now back on line 18, and line 18 now looks like this. If true, then blah, blah, blah. So what would be the next line to execute? The condition of the conditional statement is true. We go to the then branch, okay, which is on line 19. Line 19 doesn't do much. All it does is to print the word found on the monitor somewhere. And, this is line 19, not 119. So when we are done with the conditional statement, we get to the end of the main subroutine, which is on line 23. And then at this point, we are deallocating. Well, first of all, we take note where we need to go back to after this. So that's going to be based on the return info cell. And then we have to deallocate all the columns. So this time we have 6 columns to deallocate because the array itself is using 5 of the columns. So we copy and paste it, and then change these to strike through, and that's the end of the execution of this code. Are we doing okay so far with this? Because we're kind of combining different concepts, right? We're combining the concept of passing by reference with the concept of arrays. Do you think that's useful? And why would that be useful?
You're looking for a specific thing in a program, customer information, whatever it needs to be, being able to search an index library, it'd be nice to know if it's there, even if you don't necessarily need to know.
So a search algorithm is useful.
Yeah.
You can also write another subroutine to sort an array. So if an array is out of order, you can sort it so that it is in order. Okay. How many people remember binary search? Okay. So do you think we can write a subroutine for binary search?
Yes.
Well, for the most part, it would look kind of like this, right? In many ways, okay, if you want to implement binary search, what you're really going to change is really just from here to here. So you insert, the more difficult code of binary search and put it here, and that becomes a subroutine instead of using linear search, which is what this is, into using binary search, which is more efficient. Okay, well, that's one way to do it. Another way to do it is to do it recursively. Binary search is one of those things where recursion makes sense. So we'll go ahead and do it in a recursive way. Is that okay? All right. So that's going to be our next algorithm. So we'll go back to this part here. This has no use now. I'm going to delete it. And now we'll specify binary search as a recursive algorithm. Okay. Well, if binary search becomes a recursive algorithm, what would be the parameters? Let's work on the ones that has to be there. K has to be there, right? K is representing the value that I'm looking for. It has to be a parameter. Okay, I'm going to use this to start what we call comments in programming. In other words, everything to the right of / is really just a description. It's just a text description that is completely ignored by the computer. So this way I can kind of add my own annotation next to the actual code. Okay, so we'll just say that this is the value we are looking for. Okay, the other one, which has to be passed by reference, is the array itself. So X is an array of numbers. Okay, search for K in array X. So we know these two has to be here. But in binary search, we also have something else. Okay, but we'll just go ahead and start with these two. What else do we need in binary search? For each stage of binary search, beginning and end. Okay, the index of the beginning and the index of the end. Okay, so that turns out to be necessary parameters as well. So now we have by-val b, which is the beginning index. Okay, begin index of a range in array X. And then we have by-val e, which is going to be the end index of the range in array X. So when I say the range, it is the range that may still contain the value k. Okay, it's just not spelled out really long. Are we doing okay so far? So parameter b and parameter e serve exactly the same purpose of those things of the same name in the original binary search algorithm. But this time they are parameters. What do you think would be our local variable? If you remember all the variables used, there's one that is missing at this point. I, yep, or m, okay? So we'll say I. This is the index of the element that we compare to k. Okay, there we go. So given all of these things already, given a b and an e, in other words, the caller is going to have those things initialized, what do we need to do? I think we need to calculate what I should be first, right? So do you guys remember how I is computed? Yep, it's the kind of the average between the two, but we'll apply the floor function just in case it is not a whole number. Do you guys vaguely remember this part? Okay, cool. And then what do we do? Now that we have the index of the element that we want to compare to, we're going to compare. Okay? So we'll say, well, if x bracket I is less than k, then we'll do something else if, okay, I'm going to use the proper nesting of the conditional statements. Else if x bracket I is greater than k, then we do something else. And end if here. So now the question is, what are we going to do in here, and what are we going to do in here? Remember, in the original algorithm, everything is contained inside the repeat until loop. There's no loop here. I did not forget about the loop. There's no loop here. So you have to think about the problem in a slightly different way, okay? So you're given the stack of cards this big, or the range of the stack of cards that may still contain the value k is this big, okay? That is what you're given with. And you pull out the one right in the middle, you compare and go like, nope, that's not what I'm looking for. So what are you going to do next?
You have to increase the index so that you can move on to the next portion in the loop, or you have to reset it.
Uh-huh. Yep, go ahead.
Invoke the subroutine again, but change the beginning or end.
You're going to change the range, but you're going to invoke the subroutine again. Okay? So here's the fun part. So the fun part is you're just going to say here, you're going to say, whatever the subroutine that I'm calling is returning, it's going to be my return value too, okay? Because I'm just subcontracting somebody to solve a smaller problem of the same nature, okay? So we'll say invoke binary search, okay? You have to pass the same parameters. K has to be passed the way it is. X is going to be passed the way it is. And then B, in this case, are we changing B or are we changing E when K is greater than X bracket I? Assuming the array is sorted in a non-decreasing order, because that depends on how we sort the array. So if the array, okay, so let's think this out. If the array is sorted in a non-decreasing manner, and X bracket I is greater than, X bracket I is less than K, that means everything, including X bracket I and everything to its left-hand side with smaller indexes, is not going to be K anymore. So we're going to change B, the beginning. We're moving the beginning this way. We're increasing the beginning because index I itself does not contain the value K. But any index less than I cannot be the value K. Any element with an index that is less than I cannot be K either. So we are removing everything on the left-hand side. So that's why we're changing B. So now B is, the new B is I plus 1. So we use I plus 1 to specify the new B. E has not changed, okay, because the comparison did not affect E. And that's it. So whatever this invocation returns, that's going to be my own return value. So over here, it's going to be about the same thing. Okay. So we just do a copy and paste. We'll change one little thing. The one little thing we are changing, or two little things, the first one is B is not affected in this case, but E is. So I minus 1 will now specify E. I'm missing one really important thing, okay, but in terms of the concept, do we have any questions about this? I'm missing one really important part. Well, two. Make it two. Yep, go ahead.
We have to, if we're going into the false branch of the if-else, don't we need to reset I?
We do not need to reset I, okay? So can someone tell me what should I do here with this else? What does it mean if I get to line 14? What does it mean? If I get to line 14, it means, well, first of all, X bracket I is less than K is false, okay? And if I get to this else, it also means X bracket I is greater than K is also false. Okay, so that means, it means it equals to. Should I do something when they equal? Return, what should I return? No, true. We just found it, okay? So we say return true here, just a constant true. Because if we ever get to line 14, it means we have found it. X bracket I does equal to K. Is that okay? Because it is false that X bracket I is less than K, it is also false that X bracket I is greater than K. If X bracket I is not less than, it is not greater than K, and they are all numbers, it has to be equal to. Is that okay? So that's one thing, but there's one more thing. Yep, when they cross over. When B and E cross over, which means when B is greater than E to begin with, that means it is not there. Okay, so I haven't really checked that one yet. Where should I check that? Right at the beginning. So we're going to have to insert if B is less than or equal to E, then we'll do the stuff that we just talked about. This is why I don't like you to use this particular editor. It has no way to block indent a whole bunch of stuff. Okay. What about this else here? This else is corresponding to this if. So this else is saying, what happens if B is greater than E? Yep, we just return false. There we go. So this is the recursive version of binary search. Are you guys doing okay so far with this? But it's not iterative, okay? This looks completely different. Well, not completely, but it does look different from the original binary search algorithm, which is contained inside the repeat until loop. But it is a different way of looking at things, okay? So let me see if I can find some props. Does anyone have a spare notebook that I can borrow just, for waving around? Oh, no, this is fine. I'm not going to pass it around, so no worries. Okay, so let's say this is the original array, okay? And I'm the first invocation of binary search, okay? So whoever is passing this book to me, in the first invocation of binary search, it's going to say B is the first page, E is the very last page, okay? And K is whatever value I'm looking for. So I will look at the first page and the last page, basically 0 and bar X bar, and go right into the middle page and go like, okay, is that the value that I'm looking for? Nope. Okay, fine. And then when I pass on to the next invocation, let's say you're the next invocation, I'll give you the book, but I will also tell you, don't bother with some of the pages. The range of the pages that may still contain the value that we are looking for is only from page 0 to I minus 1, okay? Because I already checked, right in the middle, and it is greater than. So everything after that is going to be greater than. So then you are the second invocation. So what are you going to do? The same thing that I do, right? So you look at the average or the middle page between the first and the end of the range that I specified for you, right? So you look at that one and go like, oh, okay, it's not what we are looking for, but this time it's too small. So what are you going to do? You're going to go like, okay, but I think my job is done. I'm going to pass it on to the next invocation. But how are you going to specify the range of the pages?
Well, it's too small.
Yep. So you move the beginning, right? So you're going to move the beginning, not the end. So by the time you get to the third invocation, the beginning is going to be about a quarter through the whole thing, and then the end would be about 1/2 through the whole thing.
Basically, the range just keeps on updating.
The range gets smaller and smaller and smaller with every single invocation. So let's say by the time we get to you, okay, you get to either line 15 or line 19. You come to a conclusion, okay? What are you going to do? You go like, whoop, I got the answer. You pass the answer back to the previous invocation, and then what are you going to do? Because you subcontracted the job to him, right? You basically ask somebody else and say, well, I'll let you find that page. Whatever the result is, let me know when you're done. So when he's done, what are you going to do? You pass it along to whoever asked you to get the job done. And then you pass it along back to whoever asked you to get the job done. And then you pass it back to me. And then I just pass that result back on to the first person who asked the question. Is that okay? So that's kind of, thank you. So that's kind of how recursion works, okay? You are given a problem. You do a little bit of work, okay? And by doing that little bit of work, you either solve the problem, hopefully, but if you do not solve the problem, you create a new problem that is smaller but of the same nature. That is the key, okay? The new problem is smaller but of the same nature. So in this case, the smaller, quote unquote smaller sense is basically the range gets smaller. The beginning index and the end index, they're getting closer and closer. Is that okay? Yep.
What would happen if you used I instead of I plus 1 when you get the value to be already?
On which line?
On line 10, it says I
On
plus
line
1.
10. Okay, so on line 10, instead of I plus 1,
You just use I.
you use I. Then you can potentially get into an infinite recursion. Now, conceptually, it is incorrect because B is supposed to be the index of the first element in the entire array that may contain the value K. But because of the comparison on line 9, you know that is not the case. You know that X bracket I does not equal to K. So you should exclude I from that range. And by mistakenly, not excluding it, you can potentially run into an infinite recursion because you cannot get to the point where B is greater than E anymore. Is that okay? All right. Any other questions related to this algorithm? We can trace it, but it's going to look really, really messy because we have 5 things that we have to put on the stack. And yeah, so it's going to look a little bit ugly given that we don't have a wide screen to work with. So are we good so far with this? Okay, well, let's go ahead and take a 10-minute break. And then after the break, we'll come back and either look at more algorithms combining arrays and subroutines, or we'll switch to records. So the current time is 49, so 54. All right. Well, it's a lot of fun when to some people, programming. That's kind of like my pastime.
And I want to get that way too.
Mm-hmm.
So
Okay.
I like picking this stuff apart. Just it's fun.
Okay. Very good. All right. So we are resuming the lecture. I decided to start a new topic. So we are shelving subroutines for now.
You're not going to trace that.
The binary search code. Well, we can search. We can trace it, but it's gonna look really, really ugly.
Is it going to mess with your lecture times?
No.
See that trace.
You want to see that trace? Yeah. We can do a short array, and see how that works. Okay. All right. So let's go ahead and do that.
Messy's just messy, man.
It's going to be quite messy.
Shrink the font, shrink the page.
Yeah, we have to shrink something.
A little bit.
Yeah, we're gonna have to do something. All right.
I bet you can't see that projector at that blackboard.
All right. So we're gonna trace this algorithm, but we'll make a fairly simple array to trace. I'm debating between 3 to 7 items, either 3 or 7, because otherwise it really kind of gets messy. Okay, so that's the subroutine, and we'll define subroutine main here, and it has a local variable which is array A. This is an array of. I'm making it 3, okay, so it doesn't get too crazy, okay? Yep, that's all we need, okay? So now we will look for we'll initialize the array, okay? So A bracket 0 gets a value of 2, A bracket 1 gets a value of 12, and then A bracket 2 is going to get a value of, it has to be sorted, so it cannot go backwards. Let's say 15, okay? Invoke bin search. So what do you guys want to find? 15? Okay, so we'll look for 15. Okay, I just need to look at the ordering of the parameters. So we'll try to look for 15. The array is A, so A is used to specify parameter X. Since this is the first time we call the binary search algorithm, what is the index of the first element that may contain the value that we're looking for? 0. Very good. Okay. So 0 specifies B. And what about the end? What is the end index?
2.
It's going to be 2 or bar, A bar minus 1, but 2 is fine. So we'll use 2 to specify parameter E. And then we'll do the same thing. This is the condition. I'll fix this later. This is the conditional statement that's inside main. And if it is true, we say found. If it's not, we say not found. Okay, not very interesting there. And if, and define sub, and then we invoke main from here. So I'll just go ahead and fix some indentations, and then we can start tracing that code. They're having a really good time chatting there. All right. So I have to kind of shrink the font a little bit. Is that okay? Is it okay? I mean, can you still see? Okay. It's the trace that is the bigger problem. The algorithm is not that big of a deal. The trace is the problem. So we have line number. We certainly have comments. And this is the precondition, nothing to say about comments. And then we start execution on line 33. Return info is post. Okay, so that's the easy one. And then we have an array of 3 items, so not taking up too much space. But they're all unknown because they are basically local variables. All right. And I think I'm going to be kind and remind them that the class has started. Oh, okay. Huh? Well, it's all about the zoom control here. So we continue execution on line 24. So we have a 2, 12, and 15 initialized into array A from line 24, 25, and 26. And then on line 27, we invoke the subroutine, just like last time. And we have return info. So this time, it's going to be exactly the same as last time, except the line number is different. So the line number is line 27, but it looks exactly the same because we are only replacing the invocation with a question mark. The rest of the line stays exactly the way it was. Is that okay? Now we specify the parameters. We got K, X, and then we have B, E, and a local variable I. The local variable is the easy one because it's just unknown. Parameter E is passed by value. We used the value 2 to pass to E, so we put a 2 here. B, on the other hand, started with a 0 because that's what the invoke statement specifies. So B starts with a 0 here. And then X is a reference to columns, in this case, let's see, C, D, and E. So it's C to E. There we go. And then K is the value that we are searching for. And somebody said, let's go find 15. So we are trying to find 15. All right. So I do that other trick, which is to move this bar over here. So this way we can keep comments and the line number, stationary. All right, so we are pretty set up here. So when we get into the subroutine, this is where it gets a little bit complicated because the subroutine itself is kind of long too. So when we get into the subroutine, the first line we execute is going to be line 7. So we go to line 7. Line 7 evaluates the condition B is less than or equal to E. And that seems to be false to me because B is 0, E is 2. 0 is less than or equal to 2 is true. Did I say false? Okay, it's true. Sorry. As I tell people, I will make a really good politician. I can literally look at something and say something else without knowing it. I won't trip the lie detector. Because it wasn't a lie. It was really just my brain crossing wire. Okay. So on line 8, we're evaluating B plus E divided by 2. Well, this is easy. 0 plus 2 is 2. 2 divided by 2 is 1. And the floor of 1 is just 1. Okay. So I gets a value of 1. And then on line 9, we evaluate the first actual comparison of something in the array with the value K. So in this case, we are comparing X bracket I, which is X bracket 1, with K. X bracket 1 has a value of 12, okay? And K has a value of 15. So 12 is less than 15 is true, okay? So we say that is true. Then we proceed to line 10. So line 10 looks kind of interesting because it on the line of a return, it also has an invoke. It doesn't matter, okay? We cannot do the return until what the invoke is returning. So what we're going to do is to say, well, it's time to invoke a subroutine. Every time we invoke a subroutine, we need to remember, somehow we have to remember where to get back to. So in this case, we use a return info cell. We have to get back to line 10 because there's one thing left on line 10 to do, which is the return mechanism. But the value that we're going to return will then be specified. It will be specified later. Okay, the subroutine is going to give me the answer. The question mark is a placeholder for that answer. So now that we have set up the return info cell, the rest, they're not too hard. We have parameter k, the value that we are searching for. According to this, we are not changing. Okay, we are just passing it along, so that will still be 15. And then here comes the next question. What about x? Well, should we say reference to reference of column C to E, or should we just say reference to columns C to E? Is it the reference of a reference, or we are just passing the reference itself along? Yep, we're just passing the reference along. Okay, so it's not a reference of a reference, it is just the reference itself. Okay, because the bottom line of passing by reference is I need a way to go back and find the thing that I need to refer to. I don't need to pass a reference to a reference to do that. I can just pass the reference itself. So this is reference to column C to E, just like last time. So that takes care of K and X. Next one is going to be B. And according to this, B is the one being changed. I is 1, 1 plus 1 is 2. So the new parameter B is 2. E, on the other hand, okay, let me move this one here. E is not changed. I'm just passing E along as itself. So getting back to the trace, E is really just the same as before, which is 2. So we're just passing 2 along as E, the index of the end of the range. So are we good so far with the second invocation, how we set up the columns of the second invocation of binary search? We good? All right. So now we go back to the beginning of the subroutine, which is on line 7. And line 7, once again, is asking, is B less than or equal to E? Yep. Then we get to line 8. We are computing I. Oops, sorry, forgot about that. I is a local variable. It has to be allocated as an extra column. I forgot about that. There we go. All right. So on line 8, we are initializing I. And this time it is B. It's 2 plus 2, which is 4. 4 divided by 2 is 2. The floor of 2 is 2. So I ends up with a value of 2. On line 9, we are comparing x bracket 2 to k. Well, is it less than? Is 15 less than 15? Nope. 15 is not less than 15. So now we have to go to the else case, starting on line 12. On line 12, well, as it turns out, the else case has a nested conditional statement, which is asking, is x bracket I, which is x bracket 2, by the way, is it greater than k? X bracket 2 refers to a column that has a value of 15. 15 is greater than 15 is false. All right, so we have to go to the else of this nested conditional statement, which is on line 15. On line 15, we say, oh, we just have to say return true. So we are executing a return statement. When you execute a return statement, you are going to look up the rightmost return info cell. The rightmost return info cell is not visible right now. It is right here, column M. So you copy the cell, and then you change the question mark to the value that we are returning. What are we returning again on line 15? True. So we just change the question mark to true. It looks confusing because line 15, which is a return statement, we're executing line 15. But the effect of executing line 15 is to change the question mark of the return info cell going back to line 10 to true. But all you really need to know is to change the question mark. Okay, the question mark can be in an assignment statement, it can be in the middle of a conditional statement, it can be the value that you're returning. It doesn't matter. Just change that question mark. Leave the rest of the return info cell alone. Okay, just change that question mark. So now we are done with line 15. Line 15 is the end of the nested conditional statement, which is also the only statement in the else branch of the outer conditional statement. And, actually, it goes all the way out to, there's another level of conditional statement. So now we go all the way to line 21, which is the end of the subroutine. So now we have to first make note of where we need to go back to, line 10. And what else do we need to do on line 10? Well, just return, okay? We got nothing else to do on line 10 when we get back to it. So, but we are just making note of that at this point. And then these columns are no longer in use because we are now done with this invocation of binary search. This is the second invocation, by the way. So we change the font to strike through. Now we execute line 10. But we also have to remember the context of executing this line 10 is column G to column L. So when you look at this, and we are executing line 10 as return true, so we locate the rightmost return info cell, which is this one here, copy and paste it, change the only question mark into the value that we are returning, which is true. And we are done executing line 10. After line 10, which is the only thing inside the then branch of a nested conditional statement, that turns out to be the last thing of the then branch of the outer conditional statement. So we now exit all the way to line 21. On line 21, we got two things to do. First, make a note of where we are going back to, and then we can deallocate the columns that we allocated for this invocation. So now we are ending the first invocation of binary search. Are there any questions? No, we're good. All right. So now we are back to line 27. So let's scroll the source to line 27. So line 27, even though the original line 27 is kind of long and complicated, the one that we are executing right now is very simple. The condition is known to be true, so where are we going to go next when we execute line 27? Line 28, the then branch, okay? So we get to line 28. Line 28 doesn't really do much except to print found on the screen somewhere, and then we are done. Okay, we get to line 32, which is the end of the main subroutine. So at the end of the main subroutine, we got two things to do. We have to look up the return info cell. We have to go to post next. But then we also have to remember to deallocate everything that we allocated for main. So there are 4 columns in this case. On line 32, we deallocate all 4 columns. Then we continue on to post, and we are all done. So the end result of the execution of this pseudocode is it just printed found on the screen. That's it. But that's only because we put some really just test values into the array. So are we okay so far with this? Using recursion to implement binary search. Are there any questions about the concept, about the mechanisms, or about any part of the trace? Mm-hmm.
Yeah, I have a question. Can you pass an expression as a value to the subroutine?
Yes, you can, but only when you're passing by value.
Only by value, not by reference.
Not by reference. The reason why you cannot pass an expression by reference is because when you pass by reference, what is the parameter saying? Reference to column blah, 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 right? But if you're evaluating an expression, it doesn't have a column. It's an intermediate value that does not have a place to store, quote unquote. So that's why you cannot pass a general expression by reference. You can pass an expression by value. Doesn't matter. Whatever the expression evaluates to, that value is used to initialize the by val parameter. Okay, but by reference is different, because by reference needs to refer to a column or some columns, and a general expression does not have one. So is that okay? Okay, cool. Any other questions about binary search implemented as a recursive algorithm? Yep.
Listen, last time you told us that we can write like the condition is true as a comment. I mean, line 23 tracing one.
23.
Yeah, 23. Yeah.
This one?
Yeah, this one. We
Mhm.
have if true, then
Oh, okay. So B column B should say true is true, right?
as a comment, right?
Yep. Mm-hmm. Yep. Yep. So technically, yes, we should do that, because that explains why you took the then branch instead of some other branch, instead of the else branch. Mm-hmm. Any other questions? Okay. So the interesting thing about this class is what we are dealing with in this class, like Fibonacci, recursion, subroutines, and stuff like that, is about the same place where cisp300 is, assembly language programming. Except in this class, I use a spreadsheet to trace through everything. In the other class, I use memory map to trace through everything. But it's the same concept. Huh? You're basically just looking at memory locations and look at the values of each location. But everything that we talk about here that use a column makes use of at least one memory location. So if you are lucky or unlucky enough to have me for cisp300, I'm hoping that you guys will kind of remember, what you see in this class, because you'll be seeing about the same thing in that class. Okay, concept-wise, they are exactly the same thing. They're just, named differently. Okay. So with this, is that okay so far? With subroutines, parameters, arrays, recursion.
Do programmers use recursion all the time, more than loops?
It depends on the context. There are certain things that recursion does really well, and then there are certain things when, if you do it recursively. Okay, so first of all, let's make it clear. Recursive algorithms and iterative algorithms, iterative means you're using loops and not recursion, they are equally expressive. In other words, if you can express a particular algorithm recursively, you can do it with loops also. And vice versa. If you can solve a problem and specify an algorithm that only makes use of loops, you can actually turn it into a recursive algorithm as well. So they are equally expressive. They can solve the same kind of problems. The question is, which one is more, quote unquote, native? Which one is more suitable as the language of the solution? And that depends on the kind of problem that you're solving. Okay? With certain types of problems, recursion makes a lot more sense. And with certain other problems, iteration makes a lot more sense. Now, recursion does come with a cost. It needs more resources, because if you remember, in the previous time we talked about binary search, did we use up this many columns? I mean, look at all the columns that we have used. We used all the way to column R. Did we use up to column R, when we traced our binary search algorithm? Not even close, right? So that tells you something about the efficiency of recursion. Recursion is not very efficient when it comes to the use of memory. But every time you make use of memory and every time you deallocate, that takes up time as well. So that's an extra cost of efficiency. But certain problems, when you express the solution recursively, it looks a lot cleaner. Okay, in this class, we're not gonna talk about those particular constructs, but when you get to cisp300, you will definitely start to see why recursion is useful. Okay, that's data structure, by the way. So are we good so far? But that was a good question. All right, so if there are no questions, we're gonna start to talk about types and records. And we start with this one, live without records. So instead of reading all this stuff here, I can give you an example instead, okay? I'll give you an example. So let's say, when was the last time you guys filled in an actual paper form? Today? Yeah, what kind of form did you fill in? For the design hub? Okay, so what kind of fields, what kind of information do you have to fill in? Sorry? The hours, okay. But there are other forms too, right? You guys have registration forms, permission forms to add to a class and stuff like that. So let's say you have a very simple form. You're just trying to add to a class. It will need your first name, last name, student ID, date, okay, the section code of the class that you're trying to add to, the class code like cisp300 of the class that you're trying to add to, the name of the professor, right? So you have a lot of these various fields to fill in, but it's on the same piece of paper. Now imagine this. Instead of giving you a single piece of paper with all of these different fields to fill in, the administrative building gave you a pile of little piece of paper, like that. One piece is for your first name, one piece is for your last name, one piece is for your student ID, one piece is for the section ID that you're trying to add to, one piece is for the name of your professor, and so on. So you end up with like 20 little pieces of paper. Okay? And then you're walking along, and then you bumped into another student who was also carrying a pile of paper like that because that other student was trying to add to another class. So you threw all the paper on the ground. They were not stapled, okay? And then you guys were picking up all the paper, all the pieces of paper. Isn't there a chance that you might mistake, a piece of paper for the wrong thing? Okay, because they're all tiny little pieces of paper, okay? So that's the kind of problem that we run into without the concept of a record, which is also known as structure or struct in C and C++. It's also known as class in higher level object-oriented programming language. So this is actually the introduction into object-oriented programming in a way, okay? This is very crude, but this is the foundation of object-oriented programming. So I have an example here. For those of you, some of you, okay, who have taken a kind of higher level math class, you know that you can add two complex numbers, okay? A complex number is really just, it has two components. It has a real component and an imaginary component, okay? So that's why there's an R for real, and then the I is for imaginary. So A as a number has an R component and an I component. Each one is each one is a number or a value. B has the other one. So when you want to add those two, okay, the real component is added to the real component for the sum, for the real component of the sum. The imaginary part of A is added to the imaginary part of B, and then that partial sum becomes the imaginary part of sum. So that's just mathematically how addition between two complex numbers are defined. So now we have a problem. Well, not exactly a problem, but you can definitely tell the number of parameters to adding two complex numbers is a little bit excessive because we got 6 things. This is kind of the same thing as what happens when you don't have a single paper with multiple fields on it, and instead there's one little piece of paper for every little thing that you need to fill in, okay? So when you're calling the subroutine, it is not unlikely that someone can be passing the wrong value to the wrong parameter. Because look at this. Okay, if I just want to add x and y together and store the result back into into sum, this is what the invocation looks like. That looks pretty long. Okay, because we have to specify 6 different parameters. And what do you think is going to happen if you pass the wrong parameter? Instead of passing, x underscore I, which is the imaginary part of x, to the parameter a underscore I, instead of passing x underscore I, you accidentally pass x underscore r. Do you think the compiler will detect it and go like, I don't think you mean that. I think you meant, x underscore I instead of x underscore r. Nope, the compiler says, well, it's a variable. You can certainly use it to pass it as a parameter. Okay? So the more parameter you have to specify, then the higher the chances that you might make a mistake and pass the wrong parameter to a subroutine, which is equivalent to you bumping to another student who's also carrying a big pile of, little pieces of paper as quote unquote your, form to add to a class. Is that okay so far? Is the analogy kind of working? Okay. So what we need is a way to say, oh, things belong together. Okay, certain things is just members of one item. It's just like in a form, your first name, last name, student ID, and so on. They are really just they are all parts of the same thing. They are members of the same thing. Is that concept okay? All right. So we'll get back to this one. So now we move on to talk about types. So up to this module, we do not explicitly state the type of variables or parameters. So I'm reading this particular sentence here. And basically, we only deal with integers, and we also deal with Booleans. Okay, we just had we had 2 examples of Boolean types. So what a type is it indicates what we can do with the value. So I'll give you some examples. Let me switch to here. I don't need this anymore. What do you think is the type of this? It's a value, but it has a type associated with it. It's a Boolean. Very good. Okay, I like that. What about this? It's an integer. Okay. It can also be a natural number because natural number cannot go negative. This one can be a natural number. This one has to be an integer. Okay. What about? Okay, let me see if you guys. What about this? 3/4. There's several ways to describe this. In math, we call this a rational number. We call it a rational number, but it is, in the concept, yes, it is not a whole number. It is not an integer, okay? So as far as programming is concerned, anything that is not an integer is typically called a floating point number or real number, okay? So pick one or the other, okay? Okay, so these are types. So now let me ask you this question. So I'm going to ask you the question of true is greater than false. Does that make sense to you? No. Is it true? Is it true that true is greater than false? It doesn't make sense, okay? It does not make sense. Okay, if this doesn't seem to make sense to you, let me try this one here, okay? What about 45 and, okay, negation probably works better. What is this? Not 30. No, it doesn't make sense. Because negation should only work on true and false. Not true is false, not false is true. No one tells me what is not 30. It doesn't make sense. Okay, think about the forms again, okay? You're supposed to fill in a zip code, right? Okay, sometimes when you fill in the address, you have to fill in a zip code. And so instead of using a 5-digit or 9-digit zip code, you decide to use the GPS coordinate and stick that huge long pair of number in place of the zip code. Is that okay? Nope. It's not a zip code. So that's what it is, okay? A type is basically saying, it's putting restrictions on what kind of value you can specify, okay? But it's also putting restrictions on what you can do with those values. So for each type of value, the computer can perform a certain type of operations on those values. 23 times 4. Okay, can we compute that? Yeah, okay, most people can do it even, without a piece of paper. It's 92. Yep, good job. It took me a little bit of time because I was trying to subtract 8 from 100. Go like, well, what is 100 minus 8? Okay, all right. But what about this? What is true times 32? It doesn't make sense, okay? Multiplication is not defined to operate between two, it's only defined to operate between two values, two numerical values. When one value is not even numerical, it doesn't make sense anymore, okay? So that is what a type is, okay? It is placing restrictions on what you can do with values of that particular type. Is that okay? So now the question is, do we need to worry about this? Well, sort of and sort of not, okay? Because it depends on what programming language you're using. You're all moving on to cisp300, which means you'll be using C and C++ programming, okay? And some of you may even have to learn Java programming, because if you're transferring to sack state, then you have to learn Java, okay? Because that's what they are using at sack state. But beyond school, okay, beyond CISP360, beyond transferring to a 4-year university, when you get out there and become a developer, what kind of programming language do they use in industry in addition to C, C++, and Java? JavaScript, okay. Any? Python, okay. What else? Huh? C#, Ruby, and so on. And, say that? .NET. .NET is not actually a language. It is a, I would call it a framework. Yeah. Yeah, .NET is more of a framework than a programming language. So with all of those other languages, they are not typed. In other words, when you say, oh, I need a local variable, blah, 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 you don't have to say what it is. And at one point of time, the variable can be storing an integer, and then next you can store an address, and then you can store a name, and then you can store something that's either true or false. So those scripting languages are not typed. They're not strongly typed. C, C++, and Java, they're all strongly typed, which means if you declare a local variable, you actually have to say what kind of value the variable can contain. You have to say, oh, this can only contain integers. That can only contain booleans. That one over there can only contain text information. So you have to specify exactly what kind of value you can store into each variable. So that's why we had to bring this up, because you guys are moving on to a class where everything is strongly typed. You have to tell the compiler, or you have to tell the computer what kind of value you plan to use with a particular variable. So that's why it's kind of important. Is that okay? So the type of values that we have talked about include, okay, integers. We have been using integers all along, okay? So this should be nothing new. And then we have booleans, okay? Things that can either be true or false. So boolean is a type, even though in C and C++, integer is abbreviated to int, boolean is abbreviated to bool, okay, in C++. And then we have strings. You can just look at string as text, okay? We are not gonna deal with text a whole lot in this class, so don't worry about text or strings, okay? So now if we need to indicate types, okay, how are we gonna do it in pseudocode? So in pseudocode, this is how I would do it, is I'm gonna use a colon, and then I specify what kind of value can be stored in a particular either parameter. In this case, n is a by value parameter, but you can only specify integers for that particular parameter. We can also specify a type associated with the return of a subroutine. So we can now say, oh, binary search can only return a Boolean value. It cannot return a number. It doesn't seem to make sense, okay? So binary search can only return a Boolean, but some probably should return a value, a numerical value. So is that okay? So notation-wise, this is a slight modification. We basically just use a colon, and then after the colon, we specify what type a particular thing is restricted to. Is that okay? Okay, all right. So now we are moving on. So, well, as much as you don't want to see binary search, here's binary search, and this is the non-recursive one. So when you look at the non-recursive version of binary search, you can, this is before I change my note. So this array should be passed by reference, so change this from value to reference. So A is an array of integers, K is an integer, the return type is Boolean, which means I can only return true or false. I cannot return a numerical value. Local variable B is an integer, local variable E is an integer, local variable M, which is our I, is also just an integer. So now we are placing restrictions on the variables and the parameters because that's basically what your next class is expecting. Is that okay? But there's another reason why we have to start to talk about actual types. It's because when we move on, we start to talk about records. So what exactly is a record? A record is a named collection of data members. Is that meaningful to you? No. So it's basically saying it is a collection. Okay, so let's dissect that particular phrase here. Okay, so a record is a named. Okay, what does it mean when I say named? It has a label, it has a symbolic name. Okay, you can refer to it by its name. Okay, so in this class we don't talk about anonymous records. Every single record type has a name. You can refer to it. That record type, that record type, that record type by name. Okay, so that's what name means. Named means. Collection. Okay, what do you think the word collection is meaning here? Has potentially multiple things inside, right? This is a collection, which means it has members, it has components. Okay, so what do you think the components are called? Well, they're called data members. Okay, and it can serve as a user-defined type, which means once you define a record type, you can use it as a new type. This is how you can define new types on your own. So here's a definition of a record type. So in this class, in pseudocode, I just use record and end record to contain the definition of a record. The name of the record is right here. So complex with the uppercase C, intentionally uppercase, is the name of the record. And it has two members. Can anyone guess the names of the two members? I and R, okay? So I is the name of one member, and R is the name of the other member. What are the types of each member? They're all integers, or numbers, I don't really differentiate between integers and real numbers in this class, but in the C class, you will have to differentiate between those two. Okay. So how do we make use of a record type? So this is the example of complex ed, but this time we are making use of the complex type. Let me scroll up a little bit so that we can see both the definition of the record type and also the subroutine that makes use of the record type. It looks cleaner, okay? Looks like we got fewer parameters, right? So instead of having, A underscore R, A underscore I for the two components inside A, I just say, oh, there's one parameter A, but what is the type of A? It is not a number anymore. It's not an integer, it's not a real number, it is a complex. What is a complex? How do I know what a complex is? We just looked it up, right? Okay, it's a record and it has got two members. It has got two components. The first component is called I, the second component is called R, okay? Same thing with B and same thing with sum. So now I'm treating an entire complex number as if it is just one thing, okay? So instead of having 6 parameters, I now only have 3 parameters. But then what do we do when we need to refer to the items or the members inside a particular complex? Well, then we can use a dot notation. So a dot R is, you can look at a dot as apostrophe S. Let me say that one more time. In object-oriented programming and in most programming languages, the dot notation is kind of like apostrophe S in English. Okay? So a dot R is saying, oh, we want to refer to member R of A. Is that okay? So we are adding member R of A to member R of B. Can we add 2 numbers? Is addition defined for numbers? Yes? Okay. So this will make a sum. What are we doing with a sum? Well, we're going to use it to change something. What are we changing it? We're changing member R of sum. Sum itself is passed by reference as a complex type. So are we doing okay so far with this? So if you look at a record as a form, then you basically is looking at a form and you have different fields, like first name is a member, last name is a member, student ID is a member, okay? Address line 1 is a member, address line 2 is a member, zip code is a member, city is a member, state is a member, and so on. Are we doing okay so far with this concept? Is that okay? All right. What is the relationship between, let's see, what is the relationship between A and complex? What is A? A is
subroutines. You're defining A by multiple things.
A is a parameter. Okay, and what is complex to A? It's the type, exactly. So complex is the type of parameter A. Complex is the type of parameter B, and complex is the type of parameter sum. Is that okay? It's kind of like saying, to get a job done, you need 2 people and a dog, okay? Then, in order to assign people to get that job done, you need to say person A is Tommy, okay? Person 2 is Mary, and then the dog is Fido. Is that example working? Okay. So we can change the main program as well using types. So instead of the main program being, okay, we have to scroll all the way back because it's at the very beginning. So this was the main program before. We have 6 local variables defined, like here. And then when we invoke complex sum, this is a really long line because we have to specify 6 different parameters. But once we can treat a complex number by itself as a single thing, the main program looks a lot simpler as well. This is the new main program. See how less complex it becomes? Because now we can say, well, when we declare x, y, and sum as local variables, we only have one x, one y, and one sum, because the components are contained inside each one. Is that okay? Okay, I see some frowning, so I'm waiting for questions. Questions? Nope. Okay. When we pass the parameters, we can also treat the entire x, including both the r and the I components, as one thing. And then we just say, oh, look at this x here. Use it to specify parameter A. Look at this y here. Use it to specify parameter B. And look at sum here. Use it to specify parameter sum of the subroutine. So instead of having to refer to the R and the I components over the place, I only need to refer to those when I'm initializing the components inside X and Y. That is, I cannot avoid that part, okay? Because I do have to break out the individual components for the assignment. But once I have all the assignments done, I can now treat X as one thing, Y as one thing, and then sum also only as one thing. Are we okay with this? More or less? Does anyone want to see how the trace is going to look like? How a record is represented? Okay, let's do that. Because I think sometimes the trace actually helps explain the concept more so than just looking at the text and go like, oh, this is a record, and we are looking at all the as a record as a whole thing. All right, so this is the sample code. Are you guys comfortable with the use of a complex number? Because I can change it to something else. It's okay? It's all right? Okay. So complex has I as a number, R as a number. The order is not important, by the way. Okay. Oh, by the way, just by this thing, the record definition by itself, line 1 to line 4 here, do you think by this much do we have to allocate any columns? Nope. A record definition is just like a definition in a dictionary. It is really just a description, but it doesn't take up any resources because we don't have an instance of that record yet. Okay? In other words, you can look at this as a dictionary or an encyclopedia description of a great white shark. Okay? Do I need to prepare my aquarium? Do I need to worry about the salinity of my aquarium because, hey, I have a great white shark here? Nope, because this is just a definition in a dictionary. It is not an actual great white shark. Okay? All right. So now we have define sub complex sum. And then we say bival A is a complex. Bival B is also a complex. By reference, sum is also complex. A.R gets, sum.r gets A.R plus B.R. Sum.I gets A.I plus B.I. And define sub. Fix the indentation a little bit. So now we're into main. We have local variable, I think X and Y. X is a complex. y is a complex. And now we have to initialize the components of x and y. So x dot r, I'm not going to use exactly the same thing as in the notes, so that might be slightly different. X dot I is -4, and then y dot r is 1, y dot I is 7. Then we invoke complex sum. We use local variable x to specify a, local variable y to specify b, and then local variable sum to specify parameter sum. There we go. Okay, we've got some indentations to fix. All right. So now we can start to trace it. We got line number. There's no need for comments because this one does not contain any conditions to evaluate. So precondition is nothing to specify. On line 21, we specify return info to post, same as usual. Now we have 3 variables to allocate. The first variable to allocate is x, only 2. We got x and y to allocate. So we got x, but x does not use one column anymore because x has 2 members. X is a complex, and every complex has 2 members. Each member takes up 1 column. So when you look at x, it has 2 members. It has member I, it also has a member R. So it actually takes up 2 columns. Local variable x, if I want to denote it using columns, it's actually taking up column C and column D. So column C and column D together is representing local variable x. The same thing applies to y. Yep. Mm-hmm.
Is there a reason why we wouldn't want to do like x dot I?
You can do that too. That would be the same. Yep. So if you want to do it with y, we can do it this way with y. So we can say y dot I is 1 column, y dot r is another column. The only reason I kind of want to do it this way is it gives you the ability of having members that contains other members that contains other members, because they can nest. Okay, but it's okay. I mean, for now, that's fine. We can do it this way. But these are all local variables, so that's why they all start with unknown values, like that. And question mark. Question mark. All right, so when we get to line 15, x dot r gets 2. Which column are we referring to? Column D, very good. So 2 goes here, and then -4 goes here, and then 1 goes here, and then 7 goes here. So that's how we initialize the 2 local variables, x and y. 16, 17, and 18. Now it's line 19. So we got some really interesting stuff going on here, because x and a and b are passed by value, and sum is passed by reference. So now the question is, okay, first of all, let's deal with return info first. So you can either use a return line number or return info. The reason why we can go back to use a return line number is because complex sum does not have a return value. Okay, so if it doesn't have a return value, you can just use a return line number. But if I want to borrow the concept of return info, it's okay. It's just kind of tedious, because when I get back, from the invocation, I have to go to line 20, which is end define sub. I have to spell the whole thing. It just takes up a little bit more space. Is that okay? So I could have just said, return line number is 20, okay, which is a little bit more concise. But if I insist to use return info, this is what I need to do, because I need to go to line 20 when I'm done. And what do I have to do on line 20? We are ending the invocation of a subroutine. Okay, so this is just to illustrate that we can now use return info for everything, even though it is a little bit more tedious to specify. But then we also have to set up all of the other columns. So we have to set up parameter A, parameter B, and sum. Sum turns out to be the easier one, because sum is passed by reference. So it becomes a reference to columns, okay? Multiple columns. Which two are we talking about? Oh, I forgot to allocate. Oh, I did. Yeah, we didn't define it in main. So in the actual program, it would have failed compiling. because this sum here, this sum is referring to something that is not defined, which implicitly in this class is global, but I didn't specify as a global either. So this is my little problem. So I'm gonna have to fix it. The problem is if I insert. The problem is if I insert any code here, like local sum, complex, it's gonna shift the lines, line numbers down. Yeah.
Before line 19. Can't you add it before the invoke?
You mean add a local here?
Yeah.
That's a good question.
Like before.
It depends on whether you're using C or C++. In C++, you can do this. In C, you cannot. But we'll just say that we're using C++. So in C++, yes, you can do a local anywhere you want. So you can actually specify a local here, and sum is a complex. So yes, you can do it like this in C++. So we just have to shift one line here and one more here. Okay. But this also has to change. When we come back, it's going to be on line 21. And we also have to shift all of these over. So we're going to have to add 2 columns to the left, because we have sum.I and then sum.R as new columns. All right, so that's definitely my bad, because I forgot. So these will start with unknown values too. All right, so now that we got that done, it's columns G and H. So parameter sum, not local variable sum. Parameter sum is going to refer to columns G to H. But the bigger problem now is A and B. Because A has 2 members, B has 2 members, because they are passed by value. So if I use X to specify A, I really have to copy both columns from X to A. So you can see how how X excuse me, has -4 and 2. I have to copy both of those. So A has 2 members, -4, and 2 are here. One is member I, the other one is member R. So A technically takes up both of these columns. Are we doing okay so far with this? So once again, we are looking at an extension of a concept, passing by value, but we're extending that concept to records. Yep.
Is there a reason why we don't use A.I and A.R as column references while we're actually putting the values there?
Because when we refer to A by itself, sometimes we can refer to A all by itself. I want to make sure that we understand A by itself is referring to both column J and column K. It's only when you refer to individual members, R or I, that we refer to just column J or just column K. So that's kind of significant in a way, because if I only use like B.I and B.R, then what about B by itself? Well, it's not clear. But now if I say what is B, and I merge these 2 cells into one, then it's pretty clear that when I refer to B by itself, it's referring to both column L and column H. So that's kind of the reason why I chose to do it this way. Okay. So once again, B also has I and R, and we use Y to specify that. So we have 7 here, and then 1 over here. Is that okay? All right. So now that we have all of this done, we can now continue to execute inside the subroutine. So inside the subroutine, we want to add the R components together, and then the sum of the R components of A and B will be stored in sum.r. So we'll handle the right-hand side first. The right-hand side is asking, what is the sum of the R components? Well, we are looking at 2 and 1 added together, so that's a 3. Where are we storing the 3? We want to store that 3 to the R component of sum, but sum does not have components by itself. What it refers to does. Let me say that one more time. Sum is a parameter that is passed by reference. So it is really just a reference to something else. You're not going to change anything in column N, but what you're going to change is component R of the columns that sum is referring to. So now you have to go back to column G and H and ask, okay, which one of you is component R? Column H, okay? So column H is going to be the one that is updated to a value of 3. So 1. So this is line 9, and column H is updated to 3. On line 10, on line 10, it's going to be column G that is going to be updated, and because that's the sum of the I component, so it's -4 plus 7, which is also 3. That's coincidental. I did not plan for this. And then on line 11, we are done executing, so we have to deallocate the columns and then figure out where to go next. Where to go next is based on the return info cell. So we just say, oh, okay, it's line 21. We are we're ending an invocation of a subroutine, and then we have to remember to deallocate all of these columns. I'm not sure how well this is going to work, because when I copy and paste a merged cell, I'm not sure whether they will stay merged or not. We'll see. Yep, they do. Okay, nice. Strike through. There we go. So now we continue here, which is the end of the main subroutine. So we are going to look up return info cell again. So we are now returning to post, and then these columns are now deallocated. There we go. So once we get to post, that's the end of the trace. Is that okay? All right. So as I said, this is the beginning of object-oriented programming. It is not yet, object-oriented programming, but object-oriented programming is, this is the foundation of object-oriented programming. The whole concept of membership, like this thing is not the entire thing. It's a collection of items. It has got members. That is one really important aspect of object-oriented programming. All right. Yep.
Probably not relevant, but you mentioned about how C and C++ sees the declaration of local sum early on in the program versus later on in the program. Why can't C do it?
That's the restriction of the C syntax. C as a programming language does not allow you to declare variables in the middle of code. You have to do it at the very beginning of a block. Yeah, but C++ relaxed that requirement, so now in C++ you can declare new variables anywhere you want. All right, so that's it. You guys have a good weekend, and I'll see you guys on Monday. Don't forget the homework. You know, it is now a graded homework, so make sure that you turn it in.
Yeah. So when you were doing the whole notebook thing,
Mm-hmm.